Hi guys. In this video, we'll be implementing another amazing project called gold price prediction using machine learning. So far we have implemented so many projects with different data sets. Even I also showed you how we can implement the entire end-to-end pipeline. If you want, you can also convert this project as an end-to-end pipeline. Okay, the same template you can use. So first of all, let me show you the data, like where this data is present. After that, I will show you the workflow. Then we'll start the implementation of this project. Guys, this is the data. You can see this data is available over the Kaggle website. The dataset name is gold price data. And you can see this is the data looks like. So it has actually different features like SPX, then GLD, USO. Okay, based on that, you have to predict the price of the gold. So here price in, you can see this is the price. So the price, you can see you have to predict in a euro or USD. Okay, you can see. So this data you have to download. So just click here, it will automatically download the data. So let me download the data. So here you can download as a zip file, and in the collab notebook we'll perform the analysis part. So this is the workflow of the project. So first of all, we'll be getting the gold data. Then after that, we'll try to pre-process the data. Then we'll perform some basics data analysis part. Then we'll be doing the tender speed operation. Then here we'll be training one model called random forest regression. Okay, so this model will try to train, and after that we'll try to do the evaluation. Okay, then you can do the single like data prediction. Okay, I think I already showed you how to perform it. So let's open up our Google Colab and let's start implementing the entire project. So to open up the Google Colab, search collab.research.google.com and click here. Just take a new notebook. So I'm going to name it as gold price prediction. Now let's connect the notebook. So notebook is connected. So here, first of all, let's import all the necessary library I need. So I'm going to import NumPy as NP. Then I need Pandas, SPD. Then I need Matplotlib. So import matplotlib.pyplot as plt. Then I need cbond, so import cbond as sns. Then I need tender speed from Scikit-learn, so from Scikit-learn dot model selection, model underscore selection, import train test split. Then I need random forest classifier. It is available inside Scikit-learn dot ensemble. Okay, I think you know that this random forest regression is the ensemble model. Okay, that's why it is available in the ensemble. And why regression I'm using? Because the problem statement, you can see it is a regression problem statement, because here you have to predict the price of the gold and it's a continuous data. Okay, that's why it's a regression problem statement. So import uh, random forest regressor. Then I also need the metrics. So from, okay, so I just need to write from sklearn input metrics. So now let's upload my data. So this is the data, let's upload it. Then I'm going to rename it, because sometimes whenever you will try to unzip, it will give you some issue. So that's why you have to rename it. Then you can unzip the data. So unzip, just give the data location. Unzip is done. Now here is the data, gold price CSV. Okay, now let's try to load the data. So here I'll just write gold underscore data is equal to pd dot read csv is equal to, oh sorry, inside that you have to give the location of the data. So this is the location. Then after that, if I show you my gold data, data dot head, this is the data, guys. Okay, So here you can see it has date, SPX, GLD, yeah, USO, SLV. Okay, so these are some actually features of the gold, and based on that you have to predict the price of the gold. And here date is not required because uh, I mean that doesn't have any information. Okay, so that's why we'll try to remove the date. Now if you want to see like how many record you have in this data, so simply just write data.shape. So here you have 2290 example and 6 columns. Now if you want to see the information like how many integer variable, category variable you have, you can see that. So all the variables are you can say floating, and only this date, okay, it is the object type variable. So we'll try to remove this part. And if you want to see whether it is having missing value or not, simply just write gold data dot is null, okay, and dot sum. So you can see there is no missing value in the data. It's completely fine. Now if you want to see some statistical analysis, you can also see the describe of the data. So here you will be getting mean, standard deviation, minimum value, 25 for 50 and 75, and max. Okay, these are the value. Now here like all the data you can see it is like a floating type data, and again it's a regression problem statement, so we have to also see the correlation. Okay, correlation of the data, so whether any column is like highly correlated or not. So for this let's try to see the correlation. So correlation is equal to gold data dot core. Okay, so there is a method called core inside pandas. So if you execute, so this will give you the correlation value, but here it is telling could not convert the string to float, because what is happening here, you have one this one uh, categorical column. Okay, so that's why it's not working. So what I will do, first of all we'll try to drop this particular data. So gold data dot drop, so column is equal to, I want to drop this date column. Okay, date column, and what I will do, I'll try to store inside uh, or let's do it in place is equal to 2, in place is equal to true. That means I want to do it permanently. Now let's see if I execute. Now if I show you my data, gold data dot hit, so now I think date column is not there. Okay, it's not there. Now I think this will work, so let's try. Yeah, so it is working now. It has all the correlation value. Okay, it has all the correlation value, but I want to plot it in a graph so that you can understand, okay, what is the correlation. Because by seeing this number actually I think there is a possibility you won't be able to understand. So let's plot a graph. So here we'll be using Matplotlib to plot this particular graph. You can see this is the graph we are plotting. So if I show you, see this is the correlation. So you can see this is the highly correlated number. That means if you get this blue mark, that means it's highly correlated, close to 1. And if you get this white mark, that means it's lowly correlated. You can see this euro USD, euro ASD, this is highly correlated because these are like same column. That's why this color is high and the number is 1.0. Okay, then this euro USD and SLV. Okay, you can see this is also like a little bit correlated, 0.3 around. So here you can consider. Then USO and USD, so this is having actually correlation and close to 1. Okay, so that's how I think you know that, guys, in statistics what is the correlation and how it helps us to perform the regression problem statement. So you have to understand. Okay, so with that you can understand whether your feature is has so with that, guys, you can understand your feature is having relation with your target column or not. Okay, based on that you can select the column, and if any of the columns is, let's say, highly correlated without your target, that time you can remove one of the column and you can keep only one column. I think you already learned in your statistics. Okay, I'm not going to explain. Now what we'll do, guys, we'll try to split the column between our x and y. That means here we'll try to separate out our x. So date I already removed, so I'm going to remove from here. So I'm only going to remove the GLD. That means this is my target. Okay, and inside x I don't want to keep the target, and inside y I want to keep the target. Okay, that means the price, GLD. Now you can see this is the X and this is the Y. Okay, so here one mistake I have done, guys. Instead of GLD, it would be uh, this one, na? Because this is the price. Here I will try to mention it. Now it should work. Let's see. So now we can see it is fine. Now if I show you my Y, so here is the price. Okay, now what we'll do, guys, we'll try to do the 10 test split operation. So here I'm keeping 80% data for the training and 20 for the testing. Then we'll initialize our random forest regressor, and n estimator is equal to, I'm taking 100. Again, it's a hyperparameter tuning. Okay, you can take any number. So I was trying with 100 and it was working fine. Okay, you can go to the documentation of random forest regressor, you will get it. Now let's feed the data. So I'm going to feed the data X train and Y train. Now it's done. Now if I do the evaluation on the testing data, so let's see the prediction. So if you want to see the prediction on the test data, so this is the prediction, guys, I got. Okay, now what we'll do, we'll try to see the accuracy. So for this, let's calculate the R2 score. Okay, so I'm giving the original data and the predicted data, and here is the R2 score, guys. I'm getting 98%. Okay, that means this model is working better. And if you want to see the actual versus predicted result in a graph, let me show you. First of all, let me convert this thing in a list, then I'm going to plot with the help of Matplotlib. So now if I show the graph, so guys, you can see this is the graph. Now you can see this is the actual value, this is the predicted value, and you can see both are close. Okay, that means it is working fine. So that's why I told you guys here. Now what you can do, you can convert this project in an end-to-end pipeline by referring my previous template, and you can actually complete the entire, let's say, implementation. So with that, guys, thank you so much for watching this video, and I will see you next time.